Good to have you all here. It's good to be with you. What we talked about last time was kind of, there were some individuals that were trying to figure out how to bring up a cluster, kind of some things about what some best practices. I thought the easiest way would be to kind of just go a couple of things, some basic stuff, and then just hands-on, let's just create a cluster. And then get some feedback. Like kind of things that you guys may have done, if you've done it yourselves. If you haven't, maybe you can ask a question, maybe get into it. Or if there's some better best practices, then one of them can show. That's basically the form. So let's start out with saying, asking the question is, who manages their own cluster? I know you do.
I thought it was more, I was waiting for the.
Yeah.
Yeah. Oh yeah.
Versus being managed for like EKS, AKS, Google. Okay. So everyone, who's self-managed and who's managed? Self-managed.
Yeah.
Okay. And who uses just another service like AKS, EKS, or Google? Anybody? Okay. So a lot of this stuff is not going to, you're going to like, oh, why would you ever do that? And yeah, that's a good question. But there are also some things that I think if you do your own cluster, you do see some of the flexibility that it's really can be important to you at sometimes. The interesting thing about cost is Google, Microsoft, those don't charge you for the control plane. And but there's also some things that you don't get because of that too. But I don't know why or when AWS will switch, because I think it's 10 cents per. I think it's 10 cents per master or whatever.
$27.
What was it?
20 cents an hour.
Yeah, 20, 21, 20, you know. And you're just thinking, okay, so what are they doing for me?
Our fans say it's because they have to manage the messages across multiple availability zones. So instead of Google and everybody else.
So let's just show how easy that management is and what you're paying for.
I've shown them. Yeah. And they're like, yeah,
Yeah, and it's interesting, you know, the upgrade. They say, oh, okay, no, it's not. Google is amazing. And I'm not sure of that, I'm not done with their upgrade, but Google is pretty amazing how they upgrade the clusters. EKS is kind of interesting in that regard. I think it's getting better. The issue is that, one, not everything has to be on the edge of Kubernetes releases. But there are a lot of it's moving so fast, Kubernetes, that there are some things that really, if you start saying, well, maybe not this release, maybe not this release, it's amazing how fast you get behind in the capability and just the availability of options that are necessary as you go forward in your business. There's a former company that I happen to be associated with, and some of their clusters are still on 1.7. Okay, there's some various reasons behind that, but when you think about it, going from a 1.7 to a 1.14 is just almost out. Right? That's a huge leap to go between those because they change things. And also just in the capability, just in the security aspects and the capabilities are just, there's quite a bit of a night and day between those two. So it's kind of interesting, even if you don't, in production, need to run your own, it's actually good to have these things. Minicube's cool, but it really doesn't fly. You know, when you really want to understand Kubernetes and you really want to get into it.
Too much for you.
It does. And you really can bring up something with minimal cost, especially if you're not paying for it, right? Your company is, I mean, you can bring it up and bring it down very quickly and at least be able to understand what's going on. So how many let's not talk about, how many's brought up a real cluster on their own, either just on their own infrastructure or cloud or whatever. So, okay, so everyone's familiar with kind of interesting things. In the early days, it was not easy. It was really hard. When I started with beta, when it first came out, or actually before it came out, it was not easy.
Everybody starts scripts.
Oh yeah, I mean it was just like whoa, you know, and if something went wrong, you're kind of like, okay, let's just start over again. You know, it's almost like the reboot practice. You know, you just didn't know what to do. And on bare metal, it was always weird compared to, you know, so it's just a lot of weird stuff. So anyways, so let's just say if you do build your clusters, I'm assuming, let's say, I think it's 60%-ish right now of Kubernetes clusters are actually running in AWS, not EKS, but running in AWS. I think that's just basically because they're the big gorilla, right? But we're just going to talk about Kops. Its first tier support is AWS. They are adding support to Azure as well as to Google Cloud. So it really is kind of replacing the KubeADM, which maybe some have used in the past. I think they're really trying to replace that to make it so that it can be ubiquitous across. But people using Kops, people using KubeADM or their own scripts. What do you guys use? Kops. Scripts. Any other variation of that? Kops, yeah. We, for a long time in my previous company, of course, there wasn't anything. And so we developed our own scripts.
And once you get used to them, it's really hard to go to.
It is.
There's all these cool tools, but we kind of developed a bunch of stuff around the scripts, and you're in, right?
Well, and the thing is that it's almost like
Works.
well, they're kind of doing what the managed service is doing to you, which is not a bad thing. But if you really want to know what's going on, they're actually starting to hide things that you can't even see what's going on. So what I like to do is know what's underneath it's doing, spew out in Kops particularly, you can spew out Terraform. You can do cloud formations as well. I know Terraform. You can spew out and see what's going on, because I think you really should know what really is happening underneath. Because when you try to do something a little bit different and it doesn't work, you're kind of like, well, what are they doing? Just really when you do it in your own script, it's pretty. Even though it takes a bit to get there, you just have a lot more flexibility to do stuff. But anyways, again, yeah. What I like about Kops in general versus Terraform, I don't mean to diss Terraform. Terraform is really great, and Terraform is really awful, right? We love Terraform, and then we don't love it. And the reason why is Terraform is really good, but because it's not a real language, not yet, is that it destroys stuff that you hope it would never do. And when you talk about databases and clusters and things, you kind of worry about those things, I know they're trying to fix that with a real language and real constructs and all that stuff and other things. Welcome. But the issue is that sometimes it's kind of scary when you want to do a little tweak or a little upgrade. That's one thing I can say about Kops. I don't know if you've done upgrades or other things like that. It's pretty slick. It has that same type of a thing of a plan like Terraform does. You can kind of preview what's going on, what are the changes. But it really won't do bad things unless you really tell it to do versus, oh, I didn't realize that was going to happen with Terraform. Anyways, so I like it for installation, upgrades, and just overall management. Management, there's a little bit less on that side. So for those that just came in, how many have created their own clusters before? Okay. Yeah. All right. So we're talking about using Kops on AWS tonight. Interesting feature set, as I mentioned, they're going across GCE, AWS, of course, and I think Azure's coming soon. It really does do a nice job, I must admit, in the high availability. You can specify the number, we'll show the configuration, but your masters can definitely be over AZs, your nodes can be over availability zones. It really is quite nice. There's some other things we can talk about it. Terraforms, add-ons. I don't know, who uses add-ons in Kops? Yeah, I don't get it. It's a little bit interesting. Yeah. You can try it, but I think it's at that point, once you get to a certain point, I kind of like a little more control than what it gets you with the add-ons. We can talk about all that other junk. The CNI and networking, it says 8 different ones. It knows about them.
Which ones do you actually try to use?
Yeah, well, definitely Calico is used. I use it with Cilium, but there's some nuances there that we'll talk about. So I'll show you how we're doing that. The others I am, we'll weave. what is it, Romulus? I can't remember what that thing is called. There's a bunch of them on there. And I haven't ever done anything from migrating from Cube up. I don't know if anyone's ever done anything. And then, yeah, there's a bunch of stuff you can do with it. So, all right. So, again, prerequisite. If you want to follow along, that's great. I know it's really hard to do in a very short period of time. So, kind of a work thingy demo. It'd be nice to do a full workshop where you can just do it yourself, but there's not a way that you can do it without everyone having shared accounts, all that stuff. The big thing is the prerequisite is to have an AWS account, in this case for AWS, get the domain, hosted zones, blah, 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 and all that. So once you have all that, that's cool. So what I have done, which I would consider a good practice, is I do everything in Docker, right? So I always make all my tools in Docker, and then I just upgrade the tool set as a whole. So I created a Kops image that has everything that we use or could use, well, not could use, but do use for deployments, upgrades, and such. So, for instance, in the image, it has Kops, of course. It has the AWS CLI. It has customized Helm. Just a bunch of networking tools type stuff to check things out. So, and then also, we just kind of embed some of our. I just embed some of our scripts or some of the things that we use to start things going. I'll go over that in just a bit. So let's just dive into it. So what I'm going to show is just some ideas that I've collected. Now, I'm an engineer, right? And so what engineers do, right? A great engineer is what? A great Googler, right? That's what we are today, right? So anything that I show here is just an amalgamation of a bunch of stuff that I've gathered over the course of years or so. And whether it's good or not, I don't know. I'd love to have some other best practices. But what I've kind of come up with is kind of some notes and some hardening. I actually have gathered some hardening tips that are good to go through. I'd like to augment this, and we kind of talked about maybe another. Is that big enough as far as, do you want me to lower the blind a little bit? I'd love to try to get together and try to get a best practice when it comes to security of clusters. And I think maybe our next topic, I'd really like to have somebody do that presentation, or at least lead that presentation. Because I think the thing is Kubernetes is getting a lot of attention. And because of it, just like everything else, when you get a lot of attention, then you get hackers and other things. In fact, was it Lyft? I think it was, I shouldn't say who it was. But anyways, they got hacked. And of course, they got hacked by dashboard. The Kubernetes dashboard. They didn't secure it as they should. So anyways, there's some interesting stuff there. But anyways, I just want to start out kind of some of the notes that I have. So the big thing is in AWS, as you know, I'm assuming some knowledge of AWS is very similar to the other technologies, other cloud service providers. You have a virtual private, what is VPCs? Wow, thank you. So like, what's the C? You have a network space, you have subnets, you have load balancers, you have instance types, you have permissions that are based on roles and policies that you have. There's a bunch of stuff that you have. And I'm just going to go through some very specific ones that are necessary. One of the interesting things is in the olden times, it was kind of hard to have multiple clusters in the same VPC. And not even the same VPC, the same environment sometimes. And so one thing that's kind of a got you, not really got you, but first thing you need to do is what VPC you want to put this in, and then each subnet, okay, your subnets are going to be related to the availability zones, right? You're just going to label those, you're going to add these tags, right? You've probably done this already. And so what's nice is you can have various different clusters in the same VPC if you make sure that you add that top cluster name for each different cluster. So So you just add that for each different one.
So are you dedicating subnets to a single cluster, or clusters share subnet?
They share. Yeah.
That was a big problem early on.
Yeah, and in fact, this is kind of yet another. Where's my browser now?
Using the native Amazon networking, they have to have dedicated subnets because they're fucking people to match nodes. Oh yeah. But if you're using anything else, if you're using anything else.
Where is my browser?
And they share not counting.
Okay. So for instance, let me just show you kind of what's going on here. Can you see that? Yep. Let me get a little bit higher. So let me just show you exactly what I'm talking about inside of your VPC, so everyone's very clear. This is our dev environment. We happen to be out in Oregon right now, in our primary world. Subnets. So we have, well, because it's Oregon, right? We just have a couple of, well, we have 3 privates and the 2 publics, right? So I don't know about you, but I don't do public Kubernetes clusters.
That'd be a good practice,
Okay.
a good best practice with number 1.
Yeah.
Don't give every node public IP.
I just don't do that. It's just they're not there yet, or we're not there yet as a community to do it right. And so my best practice would be never in a public VPC. You can do it through a kind of a DMZ-ish, you know, you can do some ALDs or whatever, Nginx, you know, you can do it the right way without exposing really Kubernetes to the public. So my suggestion is always private subnets. You can do your VPC peering and all that stuff that you need to do. You had to, but that's number 1. Don't expose Kubernetes in a public way. Okay, please.
Just to be clear, like, it is sometimes easier to do Kubernetes as long as your security group doesn't allow traffic.
Sure. No, and very much. It's a lot easier.
Right.
But for me, I think because we know what we're doing, we hope we do sometimes. It's people next to us or that come after us that they don't realize what they do when they change something, and all of a sudden, boom, you're right in. Versus, it's nice to have. I've always come from the old school where you do have a DMZ, where you have that, your search, your private search are here, not way down below, right? And you need to do your things. Your big security, controls and penetration is right there, so you're not trying to spread it all out. And so that's what I'm saying, that there are a lot of things in Kubernetes that if you do keep it in a public way, that you expose a lot more than if you just kind of keep it private. And we can talk more about that. So very quickly, so let's look at one of these tags. Right here, you can see that there are actually 2 clusters defined. You don't need to put these in separately. And one thing again, because it's a private, it's an internal ELB, not a public ELB or external. And so there are actually 2 clusters defined here are actually Dev 1 and the one in the meetup that we're going to create tonight. Okay, so that's the kind of thing that you just need to make sure that you do when you set it up, is just get that going. And again, type of private and all that type of stuff. I already have an instance out there that I have. Okay, let me just back up. Okay, another little tidbit that I like. Well, I can't really find. I do not like keys and secrets on my box. I just don't like it. It's just a bad practice, because why? There are bots loving people to put them where? In GitHub. Right? Oh, I forgot. And they just troll constantly for
GitHub will tell you.
They do now.
Amazon credentials in GitHub.
They do now.
Yeah, they do now.
They do now, because what's been nice is, anyways, they do now. But even so, I'd rather deal with the notion that the instance has a role, and I give that instance the role. Again, it's a one place where things are. I can secure that place, SSH keys, all that kind of thing, and I give the rights that are necessary there.
That's actually one of the best practices too.
It is.
These IAM roles, they're automatic credentials, they're rotated behind the scenes and all that good stuff.
Yeah. It's just a better way of doing it. And again, I'm talking about in a production environment, you can do what you want, elsewhere, but
Also easier.
it is much easier because you're not worrying about things. You're not worrying about different accounts. You just know that instance is there. So basically, what I have done here again is I've created this. Let's go back to here, EC2. For those that know me, I'm a CoreOS guy. So I created CoreOS. We have our own CoreOS image, and that's if anyone wants. I actually use Packer to create our own, so we have our own stuff in that image, so the own AMI. And we actually encrypt all the volumes, which is kind of interesting that people don't realize that on some of your instances, your root volume is not encrypted on the marketplace AMIs. And so the problem with that is that you have to do that for every account because the encrypted volume, encrypted AMIs will not go across, right? Because the keys are stored within inside that account. But it's really easy to create them. I just have a script too that just creates AMIs in the account and they're done. But I would suggest that if you get into this world too, that you create your own AMI with the security that you want in it, the keys that you want in there, as well as there are things that people just take the vanilla AMIs and you're not optimizing your ARP tables, a bunch of other things that you're going to run into later on when you try to scale up. So there's some kernel tuning that we do and other things like that. So that's what we have, this little provisioner. And so what I do is I just SSH into it. Again, I have a key. Let's see which one it is. I think it's that one. Oops. And so again, I just had to download it before and it's loaded. And so this is that image that I'm talking about that has everything that I need. And again, this instance type, I should be a little bit more careful in what I'm talking about here because I'm probably going a little bit fast for some that don't understand what we're talking about. But the instance type itself is going to have this this Cadence provisioner role, okay? And that is going to have all the things that are necessary for Kops to create a cluster. Much more privileges than, this is Uber privileges, right? This has pretty much control of EC2 instances all the way, Route 53, you name it, it has rights to auto scaling zone, groups.
So you're going to provision it from that box.
That is correct. So I have a role that has got the right rights that are necessary in it to do what it needs to do. I've secured that one box with an SSH key that's owned by the DevOps world, whoever. And then I know that it's all self-contained for that role on that box only. And that's where we do our updates. Everything we do is and what's nice too is then we just bring up a new image if we have new stuff, and I'll show you how we can maintain the stuff. But then we just have all the stuff and off we go. So
credentials on your machine isn't the end of the world if you enforce MFA for all action.
that's correct. But again,
you have to, it doesn't matter if you put it on GitHub,
right.
Like, so you have to have your phone.
Yeah, SSH keys are going to be a thing for everybody. And there are many things out there like teleport. There's some nice ones that do some stuff, to maintain those SSH keys. But really to have a box that anyone can go to that has rights to. That's where your rights are contained.
Except that you don't know who did something from it?
That's an audit B question that you can put in.
Okay, that's it.
Right. And that's what I'm saying. There are actually open source utilities that do provide these auditing type things that actually puts a little thing on there that when you SSH in, it'll actually give you a full replay if you want. There's some open source ones if you're wanting to know about that, but that actually do that. So it can maintain your SSH keys and also know what people are doing. But this has all the needed permissions, and let me just kind of show you what they would be, because they're they're numerous. And so for those that know what I'm talking about, you know, like those are always kind of like, oh, you know, but you kind of need them for again, bringing up a cluster. So you have EC2, all rights. I try to limit down somewhat of the CloudFormation stuff. Some of the encryption stuff if you want to do some key management stuff. And then look at your IAM access roles. Again, I could have done star on this, but when it comes to IAM roles, I really want to be very explicit is what this should do.
Your generated policy.
Mm-hmm. With, again, not Paul, I'm a Googler, right? So, you know, I've assembled what I've needed for all the things, because this also includes things that when you want to do spot instances or other instance group types, this manages that. The roles that you need to do. When you want to do external DNS, for those that want to do automatic DNS creation on services and addresses, this also has the rights that are necessary to do those type of things, as you can see. So these are kind of the things, and this all are scaling. These are some things again that you find out after a while what you don't have, and then you keep the list up. So and again for logs if you needed to do stuff. So that's kind of what that entails. And so what I usually just do then is just go into the, that's right. That big enough back right there? You good? Okay. So what I have in my container is then some things that are necessary to get things going. Again, I have all the binaries that are needed for like utilities and tools. But there's some other things that I have in here that kind of make us really easy to just cookie cutter to different environments. Okay? I'm only going to show what I have here. So in our real environment, this setup is, we have it for every environment that we want. So this is where you would place, and we'll look at it right now. In fact, I'll look at it with a real editor here. I think it's real. In that, it has the things that are necessary just to get the things set up for that particular environment. Again, this is all GitOps type stuff. It's all checked in. It's all part of an image. There are no keys in here. There's just things that are normally known to that particular thing. Again, the only thing that really are changeable or needed is like your cluster name. In this case, I talked about by default, Kops is really good about HA. So it can go across multiple zones for your master nodes as well as for your worker nodes and minions. Okay. So again, I'm only doing one zone tonight. I'm not HA at all, but this is where you'd add more and more right here. You just keep on going and adding the subnets and such. And as you can see, there's just a bunch of stuff here. Again, it's my CoreOS image, Kubernetes version, etcd, which you need to upgrade when you get to that world. And then your types, your instance types. Security groups are kind of interesting too. I'll talk about that later. But these are kind of very generic security groups. This is somewhere you may choose to have a different security group for a master versus a node. I'm just keeping them together today, just for again, it's only allowing 10 dot to come to talk, not anything outside of AWS. And then you can see the subnet. So here you kind of have to know, and here you have to kind of know, you know, these are some things that you have to know per environment. So what I've done prior to tonight is I've created a Route 53 zone for meetup.net, and I know which subnets I'm wanting to do in the zones. Okay, so what I do with this is then I go into this environment and I just source that thing, and then I'm all my environment variables are set up, ready to go. Okay. The first thing that you do with Kops, and what's nice about it, but also you have to be very aware of it, is in this environment in AWS, you create a bucket, an S3 bucket. And that's where it keeps all its stuff. But you know that all that stuff is really important stuff, right? It's really the crown jewels of things, like private keys and SSH keys for your TLS between things. You know, the actual config of the admin password and blah, blah, blah. So it's really important that that bucket is secure. And by default, some people don't realize that it's a good practice to actually encrypt your buckets by default and that such. So here's a little script again. I just know where I'm supposed to be on the region if I have it, and then I make sure I encrypt it, so everything's all encrypted in my environment. And if I really wanted to get fancy, I could probably provide my own key, my own ACM key, right, for the encryption of the bucket. But in this case, I just let it be what it is. So I've already created a bucket running this script, so I just do create bucket. And then after that point, then once I've done that, let me go back to kind of some notes here that kind of explain at least what I do that may be helpful. Is then I just kind of go down this little playbook for me. So I've done this, created that. I already have created the bucket. Now this SSH key, you could provide your own. I tend to also like having separate SSH keys per cluster, smaller flash radius type thing. Again, if you have a good way of managing those keys. But this just creates the SSH key for us. And again, it's just a standard. Please.
We're pointing out that when you create that S3 bucket, if you don't have the provision setting on, you won't be able to roll out updates.
That's correct. That's a very good point. And I think what you're talking about is here.
Yeah, but the bucket version.
Yeah. And so, yeah, you can set up at once if you don't do that. Or you have to create a new name for your bucket or your cluster every time. So thank you for bringing that up. And then basically I just have a script that then does the creating of the cluster. So let's just look at what the create of the cluster would be. And you're gonna go like, what is going on here? It's really not that much. It's this bottom part right here. Let me get rid of that. So you guys can see it in the front. So that's really just invoking Kops. And it's again invoking it with all of the environment variables that I set when I sourced that little script. Right? And again, for each of our environments, this is how we kind of just cookie cutter it out. Really, the only thing that's you'd say, well, why do I have 10 dots? Again, that's the standard list for us. That I'm only allowing SSH access from inside of AWS, which we have to get into and all that kind of stuff. So that can be standard across any account. But as you can see, everything else is pretty much part of what you see in the thing. Just a couple of side notes. Again, it's good to secure, encrypt your etcd storage. There are a couple other things. Again, private networking is what I think one should do. Internal load balancers. I'm trying to think if there's anything else. And etcd version. So when you do an upgrade of your Kubernetes cluster for a different version, what do you first look for? Let's say we're going from 112 to 113. What do you normally do? What's a good practice? Yeah, it's not on 113.1, it's not 113, you have to go to 113.0, any of the .0s. You go down to the bottom and you say, what's the compatibility? And a lot of people don't realize that that's really needed. You run into problems if you don't follow that. And so in there, it'll talk about what Docker version they support. So for instance, 113 is 18.606. Right, so in my provisioning of my CoreOS image, I enforce that Docker version is the one that's used on there. As well as what the etcd, and the reason I'm bringing this up is because the etcd version should match what is the standard or the one that's proved out for that version of Kubernetes. So just be very careful, and also the things that are added onto that, meaning these add-ons that we'll talk about, such as QIM or DNS or Core DNS, all of those have versions that they say are acceptable for that particular Kubernetes. So just be aware of that when you're doing upgradings from the that's a minor version? Major version, I guess. Yeah. So as you can see, it's pretty easy there. So all I'm doing here is then I create cluster.
I don't know what zone 1, 2 would be like the extra for super.
Which one?
Like, you know, because technically the first one is major, right? Major, minor, task.
Yeah, it is. So
We don't ever go to Kubernetes 2.
no.
Like, not,
Well,
I mean, someday.
yeah.
Maybe.
I don't know, but
I don't know.
anyways, so basically that's just invoking Kops with all those environmental variables that I've set up, and it's then showing what it's done. So if you have never seen kind of what it's done, it's pretty ugly, but it's a lot of stuff, and you can see that it just really spewed out a lot of things. Again, this is in its own format. You could actually spew out the Terraform files for it to really see what it's doing. But this gives a good overview of some of the things that are pretty interesting, such as our scaling groups, how they're doing that, EBS volumes. I've specified what I want for various node sizes, for the masters, for the others, so that, that type of thing. So anyways, I'm not going to go through this, but this is how you can kind of look at some of the things that it's doing. So now my question will be, for those that have done this before, is the cluster created? No, not at all. So the create cluster really is getting it ready. So what it did is this. We created that bucket, the S3 bucket. And so in that script that does the create cluster, when it invokes Kops, it's saying, here's the bucket to store everything. It's doing all the stuff, the preliminary stuff, and it's gathering all that stuff, and it's shoving it up into the bucket. And it hasn't really done anything to create the cluster yet. But it's created all the basic stuff that is necessary, and it's storing that all into the S3 bucket. Okay, so that's what it's done. But you could create it right now, but there's some things that, again, some better practices, I think, that I would suggest you follow up first before you do that, and that's what we're going to go through right next. So what I would suggest then is that as you bring your own, and again, if you guys have other like tidbits, please bring them out. I always make sure that we encrypt etcd at rest. Now that happened 110. I think it was like alpha and 110 that they provided that. And again, encrypted at rest. Before etcd, the stuff on the drive was clear text. If you could get on etcd, it was there. The secrets were there. Okay. So what this does is that it then sets up so that I do get that in the etcd encryption. Excuse me. Inside the configuration, but it's actually different than that. It's you are specifying, and again, is it really secure? Right, nothing really secure, but it's okay secure. What it's doing is you created a symmetric key that's placed on the masters, and so you secure the masters no matter what. And so they're saying, yeah, hopefully they're secure. And so the masters hold this symmetric key that I'm going to generate right here. And then when it grabs stuff from etcd, the master API servers and all that stuff, and it grabs that, then it'll decode using that symmetric key on the master, and then send it across to the pods, or the nodes actually, to the secrets to come up. So that's what this is doing. So this is just saying, okay, create a configuration, and again, we can just look at what that's doing. It's just creating, well, it's doing one to another one. Inception. It's just creating a random, and again, this is not the most secure, but it's not bad. It's 32 bits of randomness, as as good as anything. But then it creates this configuration that is now then put into the Kops configuration that then will allow it to be created with the encryption at rest. Does that make sense? Are people doing that? I am assuming. Okay. The key is once you've done that, then once you've created that, then there is this notion that you create this, and this is kind of telling Kops, okay, here's the configuration that I want you to use. Oops. And so at this point, then Let me move this up a little bit. Sorry, guys. Of course, that was not what I wanted. There, let's get that. And so this then will take that configuration, again, do Kopsy things, and puts that into the bucket so that when we actually create the cluster, that file will then be put on the masters, and voila, the etcd will be encrypted at rest. Okay, we're almost there to create the real cluster. So once we've done that, there's a couple other things that you need to do. Now, this is where I've kind of collected it from a bunch of places, but first of all, even though you've done that, you still have to tell it that you want encryption to be true, right? So we're going to actually edit the configuration. There's a Kops edit cluster, brings up an editor, and we're going to edit things inside of that, which is that configuration, right? And some of the things that we're going to do, I'm just going to go over them quickly because I actually am having a file so that we don't have to do it one by one. But it's such as making sure that I do the encryption is true. One of the things that is, if you do use ELBs versus an ingress, ELBs will eat up security groups, right? It needs a security group ELB, right? And in days before, actually it was a colleague of mine that did the PR in Kubernetes for this situation in which now you can have a shared security group for your ELBs in Kubernetes. And so then by default you get 50 without calling up to AWS to get more. And they like to do it because it means more. But it's by default 50 ELBs. You get 50 security groups. They are, but they don't like you to go very big. And it's just like Nginx. What's happening is as your rules get bigger and bigger, right, it gets slower. So they don't like you to get up to more than a few. There are people that I know that have gone up to like 1,200 and 1,400. You know, that's when they kind of like, what are you doing? But anyways, we won't talk about those other individuals. But so this is kind of where you actually specify the security group for your ELB so that you're sharing it, you're not running them out. And again, this is where you specify your core DNS versus QDNS. Right? Let me back up. I should have begun. One thing I don't like about Kops is this. It's very much tied to the version of Kubernetes, and it's really behind. It's always behind. I kind of live on the edge, so I know what it's kind of doing underneath. So I go to 111.1, but I'm going to bring up on 113 cluster. But the reason I was going to say that is some of these things become default as that version of Kops advances. As you know, in 113, core DNS is the internal DNS service. QDNS is being deprecated, right, for very good reasons. But for this purposes, because it's still 111 Kops version, these are some of the things that I have to put in there. Okay, so I'll put in core DNS. Now, who uses kubectl in AWS world? Okay, who uses kubectl? How do you say it? Whatever it is. Who uses that one? You guys use that?
We've looked at it. I think it's very kubectl. I think it's newer and it's like it's more thought out.
But have you ever gotten to work?
Yeah.
It's not.
It's not.
Yeah.
There's a lot to it because it's not to go grant a lot of extra stuff. I have to go through a lot of things to roll.
Well, it's also a different model. For those that aren't familiar with kubectl and this other KIAM is doing, is we talked about having your credentials, not API keys, secrets, you know, in your application. What it's doing is it's allowing you to, again, in AWS as well as the other cloud providers, there's a metadata service. When the instance comes up, there's attached to it a metadata service. And so you can actually query that in AWS 169.254.169.254/blah. You can get versions, you can get instance types, you can get a whole bunch of stuff that's coming from this metadata service. Okay. Among those is you can actually get the credentials or the role permissions, if you will, for the instance. And so what kubedym does, it's a pod that's on all of your nodes. You don't have to run on masters if you don't have things that are needed. But it runs on the master, on your nodes. And what it does, it intercepts the metadata service. So that when a pod is saying, I want to get an S3 bucket, you don't have to worry about credentials. It just makes an AWS SDK call. And what it does is then it tries to say, well, do I have these credentials because I'm from the instance side? And it goes to the metadata service. What kubedym then does, it intercepts that and grabs that and says, okay, wait a second. I know what you want. Because pods can be on any node, right? You have to then say, well, how do I get this to work? And so what you do is you grab your nodes actually have a role that can assume any other role. And so what happens is then the pod says, I am of this type of role, goes down to the metadata service, kubedym says, okay, I know what you want. Is this node, can I assume that role? Yes. And does this role that I'm trying to assume does that have a trust relationship with the node, because it's kind of bidirectional? If so, then I am what I want to be, even though I'm not. And so what's nice about this is, again, a pod can go anywhere, not have any of the AWS keys anywhere, and still use the IAM capabilities. kubedym is an older one. The KIM is newer and it has just a different security model, but a little bit harder to get to set up, but both are good. But that's important that...
Well, the important part is without these, if you want your pods to interact with AWS services, you have to inject environment variables or
your secrets,
you just actually put IDs and keys in them somehow, and then you have to rotate them manually, it becomes a whole nightmare. And on the node, then anything goes on.
You have to do it across all of them. And this way,
it's easy, but it doesn't fly in big sets.
What's nice about it is this, and I'll just tell you, so we actually forked the kubedym in another company because we also had on-prem as well as cloud clusters. And we actually then created it so that we actually did a proxy on a proxy. So we could actually locally have access to cloud resources without having any API keys. And so,
well, if you want to put that in with credentials like you do SDS stuff,
yeah,
there's nothing special about it.
Right, but we wanted to make sure that we did all the management up here in the cloud. And so the reason why it's interesting and what I think it's useful is that you're doing this management, especially with kubedym, you can lock it down at the namespace level. You can say, at the namespace, actually on the namespace resource, you say, these are the roles that I allow any pods to use. And then at the pod level, you can say, this is my role. And if they match up, I get to do it. And so for other companies where it's really important to lock down those IAM roles and policies, this is a nice way of doing it so you're not spreading it across all your nodes. You're saying, here's the policy. All I'm doing is setting up a trust relationship, and I have to do it explicitly to allow that. So it's pretty important. All right, so let's see. This right here is setting up policies on the nodes and the master to allow the cube to IAM to do these type of things, as well as some other things. All right, I need to get going here. Cloud labels are kind of important as well. This is kind of interesting when you're talking about your auto-scaling groups and your instance groups. In this one, you give it a cloud label so that your nodes, when they come up, they will have these. And then you can do things like auto-scaling, your cluster auto-scaler, where you want to bring up your nodes, more nodes, extend. We use spot instances for some things. And so this is how in Kops you add that so that you can say, this is the name of the spot worker. So when I want to bring up that spot worker, I can then associate an auto-scaling group to that, and it will auto-scale the spots, as well as the other nodes. All right, let me get going here. For those who'd like to do different type of authentication, so we use Google for our SSO type authentication. OIDC, this is how you set that up as well.
This is something that really lacks in the managed services too. Like, you want to see EKS, going to use IAM off, and it's going to be a nightmare.
Yeah.
There's no way to go in here.
Off to what? It's not terrible. Off to the cluster, to Kubernetes.
Like,
So this is, it's not bad, but what it does is, it does work, but the issue is that for us, it's nice to be able to say, well, you're using SSO to go into your Gmail. You're using SSO to go into Fuse. You're going to SSO to do it. And so you can use that identity, have it secured in Google land, and also use that identity SSO into your Kubernetes cluster. And then you can do your RBACs associated with that to give the
Since on EKS, I have opted for opt into AWS.
Yeah.
Everything's role-based there.
Yeah.
It's one authentication.
Yeah.
Google Apps to that.
Yeah, you can do that. It's just how much you want to tie into it is the question.
So this is to tie like individual, like my personal login and login to the Kubernetes cluster.
That is correct.
Or multiple Kubernetes clusters.
That is correct.
RBAC rules that we apply on that.
And that's what's nice here is that once you set this up, this relationship, then what we do is we just use the RBACs we use email as the identity, right? As it shows there, the claim. And so then our RBACs for rules, whether they're admins or developers or just whatever, then this is tied to that Google email address. Please.
So OIDC is not the best implementation prop because it requires every client to have a secret, which is not
well, we can look at that, but it's not
the worst.
it's not the worst because
All your devs have to share some secret, and they could technically authenticate each other.
not necessarily because the actual depends upon how often you're doing your rotation of your tokens that you have to refresh, so you have to log back in. So I have to do that constantly because I have to SSO and say who I am. So you can, but yeah, it's not.
OIDC was designed for like a server to be in the middle.
Yep.
And there's no server in the middle.
Yep.
Active as if it's a server, so everyone's sharing that secret.
Yep. Again, this is just if people want to use this model. There are other models like that you can do with EKS model and others. And you look at this area, this notion, there are several options that are available to you. It's pretty convenient for us. And again, nothing's secure. So you just try to make it as secure as you can. I'm not going to go into these. These are some other things if you want to do some, these are future gates that you set flags on if you want to do some things that are like alpha or beta, right? And that type of things.
That's completely not, like you're in a managed service, a lot of those are just no-goes.
Yeah, you can't even do these horizontal policies can use as clients, or you can't do, there's a bunch of them that you just aren't able to do. You can't do alpha by any means, which is fine, but again, it limits you. Again, I think, didn't you, long time ago, do an auditing?
I did an very,
remember?
The second time I came
Yeah.
to these, I did an RBAC audit.
Yeah, and so this is how you actually very quickly turn on the logging, the audit logging in Kubernetes. Okay, so you can set that up. There's just a little nuance here that you have to kind of create this audit policy, which is a huge file that you kind of went through that sets it up, but that's how you can do that. So once I've done all that, then I can have it go. So let's just quickly, I apologize, it's kind of going over a little too much, but hopefully it gives you a grasp of what's going on here. So what I'm doing here is, this is this edit cluster, right? So this is the configuration of Kops for the cluster. I'm going to go in there and I'm going to add, I just happen to have a set of things that I just talked about with all of those values in there. And again, you may use this, maybe not. You know, for us, it's just fine because it's pretty uniform. And I just copy it. I go into the editor, set paste, because VI sometimes does weird things. And then I just come in here, and then I just go, oh, come on. My copy is kind of weird. It doesn't work all the time. All right, and then voila. So all the things we just talked about, future gates, encryption, all these other roles that we needed them to have for the node, the master, that's all there in there, okay? So once that's done, and again, if I did a bad thing, Kops will immediately come back into the editor and say, hey, you did something. And then you go like, what I do? And I don't know. And so, because it really doesn't give you a whole lot of help. So what I just did is probably not what you want to do if you've not done this a lot, because typically what I do is make a change, and save it, check it, make another change, save it, check it. You can tell that I've gone through it a few times, and I know this is all good stuff. So once I've done that, then I can actually create the cluster. This is why you came here. So we're going to create the cluster, and again, the next step here is notes here. It's just basically, in this case, I'm not doing an update. I'm actually creating it, even though it says it's an update. Let me just show you what this does. Again, this does not create the cluster. This just shows me what it's going to do. Okay, so all the variables that I had set up, or all the changes that are in the editing, those have then all been applied in here. It's only that when I do the minus yes, that now it's going to actually do the creation of the cluster. It's going to do all the tasks as you can see here. It's creating the CA, again, pretty important. It's creating the instance profiles for the masters, for the nodes. It's making the modifications that are necessary for the search, again, to be able to have compute diameter, the core system components to be able to talk to the system. And then it does all that stuff, and it says, hey, your cluster's about ready to be there. Go ahead, drink something like that. So that's basically would create the cluster. Now, what is it doing? Okay, so again, we talked about when we started this, one of the prerequisites were that I'm going to create a Route 53 entries. Remember, I created a zone beforehand. So I'm going to go in and say, okay, so what did it do? Well, it's already started. It's created the API DNS entry as well as an ELB for it, okay? And it's also created these other entries, okay? So, just as a recap on some of this, I want to make sure that you see what's going on. I'm only using one AZ, right? One subnet. I'm only having one master. I'm only having one node. And in this configuration, etcd is on the master. Okay? That's debatable. Okay? For years, I've always said do a separate etcd cluster. And I think that's a good practice, but it also is really problematic in securing it. Because as you grow things, the problem is that you know that your masters, you should have odd number of masters, and they should be across AZs. But your etcd has to be odd as well, and you do 5 in the tree zone because you have to have.
I don't think if you're not running the masters, are running etcd, you don't know.
etcd
does.
That's what I'm saying. That's what I'm saying. It's not if you want to manage it that way. Otherwise, it's trying to combine now that you have to know that etcd and the masters have to have this oddness, and also that as you go across zones, you have to realize that if you just have 3 and 3 AZs and one goes down, it can kind of live a little bit, but you're still not you don't have a quorum for the etcd. So sometimes you have to play that game of, do I put 2 in all of them? Do I put 3 in 1 and 2? It's kind of an interesting game. But that's where the HA and all that stuff kind of gets into it. So you can see that that's what's happened here. One thing I do like about Kops that I would say is a really good practice is this. You may ask, well, wait a second, why do I have 2 entries for etcd? What's going on here? So underneath.
You're doing a separate database.
Yeah. So it's interesting. Kops actually, by default, which is a good practice for performance reasons, etcd, as you remember, is the storage of the crown jewels of your cluster. And etcd it's a lot of trashing. There's a lot of traffic going on, right? Things are constantly going in and out of etcd. Not just that, but the events just auditing type things, other things that are happening on the etcd. So what Kops did in the underneath the bowels, it actually on the masters, it created 3 partitions. It created a partition, it's the normal partition that it needed, but it also created a disk partition for the events and a disk partition for the data.
Are you sure it's just partitions? Because that's not going to help you in Amazon get more IOPS. It's not going to split your IOPS.
No, it's basically trying to give you the ability if you want to do that. So you can actually configure it to supply your own EBSs and whatever to kind of get your different IOPS. So it's their way of saying, we know that things are different when etcd talks to things. And if you're going to scale up to hundreds of nodes, you do need to be careful about etcd because it'll start really churning and you'll start slowing things down. But what I do like about it is it kind of has that forward-looking thought of separating the events from the data.
Kubernetes jobs literally sit there internally.
They do.
They cycle out and they get cleaned
Yeah.
up.
And especially if you had like a pod that's constantly restarting, you don't realize what it's doing to etcd. I mean, it's not good to have those restarts all the time. But again, what it's doing is creating 2 different ones, one for the events, one for the actual etcd internal data. Okay. So you know why I talk more about here, because I'm trying to make sure that it actually come up. Let's see what happens with the instances. So you can see that these are the meetups are the ones that we created. So the node came up, and then I'm making sure, then the master came up. Okay. So now the question is, how do I know that they're real? How do I know if it's good? And this is where I'm going to be, okay, because Cilium has some interesting things in its default configuration that we may have to, if it doesn't do what I want it to do, then we'll have to do a quick upgrade of Cilium. Yeah, as I thought it would be. But what's nice is that it came up and it said, okay, I've got the instance groups, the master of the node, right? I can see where the subnets are, so I know that they're across AZs, if there are multiple ones. I can get node statuses, which will fix this one right here. And then it kind of tries to validate certain things and let me know what's going on. So what has it done? Created the cluster, created the etcds, created everything. Everything came up, got all the etcd encrypted. Everything is all ready to go. And it actually created a kube config for me that I can then use if I want to then propagate to the rest of the world. And again, where that would be of course in your standard .cube config like this. In this case, it'll actually have kind of the backdoor password for the admin, so that you know that if you had OIDC or some other mechanism, this is your fire, break glass, right? This is that you make sure that this is stored well, but that's where that is. And then you have the actual key, that the information, the certs and the stuff that's necessary. This you can then, besides the down here the passwords, you give it to your customers, your developers, is to put in their kube config. Does that make sense? Yeah. Well, and again, I'm kind of tiptoeing. You could create your own SSL certs, and then you can actually give the ARN of your certs in Kops, so it maintains a standard SSL cert, so you can just pass that public key around. In this case, we just basically generate a new SSL on the fly for each cluster. Again, if you're more secure or not, manage it. It's up to you. So in this case, you distribute this to the world. And so then at this point, then I can then do my standard kubectl, get nodes, and they're ready to go. I'm not going to go into the Cilium thing. What's happening here again, as I talked about with Kops, it supports 8 CNIs, but it supports them at a certain level. And so it started out like within a 1.law, and Cilium's gone like way up above that. And so basically to fix that one thing, I just do an upgrade of Cilium. All right, so then once I have that, we're pretty much done, but I just want to let you know also is that when we have these add-ons, what we've also done is, I keep get-offy type thing, right? So I keep all the configurations of the add-ons in here. We use customized, and it's just a kind of an easy way of doing it as well. So each of these has specific configurations, if you will. What was that? Yeah, it is. Customized is going to kube control. Yeah, it's really nice because then what it does here is then, so like for external DNS, I will have different things in it because it's going to be different DNS zones. So I need to update things in, for the various accounts, and that's how it works. I'm over time. Any other things for those that have done this on your own? Any other things you can think of that would be useful to talk about? Please.
So we CI/CD deploy the base at the start. So spin up new clusters, an entry in our job in our CI/CD with new values and stuff like that. But if you go down that road, you will never find a piece in the continual upgrade process because that's not as automated. Yeah. So there will still be somebody with a laptop or an SSH into a box or something. Yeah. So it's not. I would love to invent some sort of workaround for that. That's the one aspect of not automating all this.
Yeah, there are ways that you could pseudo automate some of this because you could pick your environments. You could actually on some of these things that are in the shell script to invoke into the environment. I can actually on the node, which we do in some other scripts, we actually query the instance, the metadata to get subnets, to get regions, to get, we grab all that stuff automatically, so you don't even need to have that environment variable. So you can actually grab it because that instance, that provisioner is in the area that you want. So that's one way you can do a lot of that. But there's still, I don't know if I can ever
run the command.
Yeah.
Update.
And there's always something. There's always something that you just need to tweak.
I still stand by the don't upgrade cluster.
Yeah, and I would agree with him.
We've got more people to manage it, but like.
Well, no, the reason I say I agree with you because that's what we did too. But you have to have some things planned and prepared in order to do this because the interesting thing is, what we're saying is that if I wanted to go from a 110 to a 111, I didn't show you here, but I could upgrade by just going into Kops, edit cluster, and where it says what version of Kubernetes, I could go 114. Control colon, right Q, blah, blah, and then upgrade, boom, and it would do it.
Maybe.
It actually is not bad. It's not bad. I mean, we have done full, 111 to 112. We've done, the individual little dots. We've done a lot of that. We've done quite a bit, and it really does work pretty well. The drawback is, as I said, there's that one-to-one version of Kops to Kubernetes version. That if you run into problems, if you're going up higher, you get into Kops pretty well to get around those because they won't support you at all.
Upgrades are fine at small scale. I just think that with how fast in the core Kubernetes, until the core Kubernetes stuff pump down more, like at a big scale, where you've got lots of things in your cluster, like there's like upgrades are one thing, rollbacks are even less rare, even more rare.
But the problem is that you do need a couple of things. One is we actually in the other place we actually created our own backup restore hydration scripts for that. It used to be called ARC, now it's called Valero, which is a really good backup tool for your clusters. The thing is, you need to have a good backup strategy. I don't care about backups, I only care about restores. So, it's really good. But the thing is also, it's not just restoring the clusters so that you can have a duplicate. The problem that we had in larger clusters is that when you have ELBs, you have F5s, you have DNS entries, you have all this different stuff, and when you try to then do that switch over, it's not an automated process by any means, and oftentimes we had to build a lot of tools just to manage that so that you don't, when you have thousands of pods, hundreds and hundreds of namespaces, that's where you can start getting weird. So if you
I'm
can,
not saying it's easier, I'm
if you
saying
can,
it's
it's much
much
easier to do side by side. If you have a smaller cluster, when I say smaller, I think under 100, I'd say, maybe under 50 nodes, 50 to 100 nodes. I think upgrading this carefully is fine. So.
We've done it a few times, no downtime, but.
Yeah, we've done the same.
By going too far.
Yeah. Sometime in some future time, we can talk about some cost-cutting things, maybe in AWS, and maybe get some ideas from other environments like Azure. But how do you manage your spot instances? Do you like them? Do you not? How do you guess them right so that you're not, having production issues? But we literally have saved about 70–80% on cost using spot nodes, but not everything. I know Clint. There are individuals, I think, that use a lot more spot instances than I would at times, and maybe he used to.
I have a full cluster of spot.
Yeah.
We have almost majority.
You have to be very cognizant and explicit as to know what your workload is and why you're wanting to have it on those spot instances.
You get some chains on there and Firefox and tolerate them.
Yeah, and that's what we do too. But I'm just saying is that I think what you have to do is analyze your workload, and say how many reserved instance types do I want to have bare, the lights are on, maybe it's not full bright, but it's on, so that I know that they're always there, because no matter what AWS says, spot instances, they go away. And sometimes they never come back up. Meaning I had one that they said, I'm not giving you any more of those spot instance types in the environment. And it was gone. And
you buy excess capacity, and if it's not there, then you don't get it.
I know, and so you just have to be aware of that if you have mission critical stuff, you've got to have something you can back up on. So.
With GCP, the equivalent of spot instances, they will only be there for 24 hours and they will go away. So if you spin up an entire 20 node set of those instances, they will all go away without preempt or anything.
Yeah. And again, databases, things like things to stick around. So, anyways, that's all I have. Any other questions or comments or best practices? Okay. Hopefully this is useful. I'd love to have somebody volunteer for maybe leading the discussion or even this presentation on security practices. We kind of over some of them, but there are actually some really good tools out there that have been developed in the last, I'd say, a year or two. That one for checking the security and two for doing castle type stuff. And I would suggest that if you're doing your own cluster management, and I'd even say for those that are using managed clusters, I would run them on. I would run these tools on them and see how good they are. How secure really they are. Huh?
Well, maybe.
Google would be AWS, I doubt, because they still don't believe it. As much as I think that it should. That would be interesting. So if anyone wants to volunteer, please let me know. I'd love to have you lead that discussion, because I think it would be really good for everyone to get more secure. Because Kubernetes is getting a bad eye. It's bad for the community, and it's really easy to do bad things if you're not careful.
And it's been so long that a bunch of these things didn't even exist a while ago.
Yeah.
It's changed so fast.
Yeah. All right.
Just
Huh?
Yeah.
Oh, thank you. Thanks for being here. Was this useful? Was it useful? Was it helpful?
Yes.
Is there a repo?
Yeah, what I'm going to do is I'm going to talk to my boss. I've tried to kind of extract a lot, because again, it's just Google stuff, and so I'll just put it in the repo and let you know. And again, what would be nice, I'll put in. We do have a Utah KDUS meetup GitHub thingy. That if you have some other things, pull requests, whatever, or other stuff, it'd be nice to get those put together in that one spot.